dividing complex numbers is a little bit trickier. And so the goal when we divide complex numbers is to eliminate the imaginary part of the denominator. This is called rationalizing the denominator. And so since we've seen that the value of I squared is -1, then that makes a real number. So the goal is to create an I squared in the denominator. If the denominator is a single term, the BI part, then that's really simple. All we have to do in examples 7 and 8 to rationalize the denominator is to simply multiply by I over I. If we do that, we multiply fractions straight across, then I'm going to get 3I on the top and 2I squared on the bottom, which remember, since I squared is -1, that becomes 2 times -1, and so our final answer is 3I over -2. That answer is fine. Sometimes you'll also see it where the -3/2 is pulled out like a coefficient, so that we can see that the B, the coefficient in front of the I, is -3/2. Those two answers are the same and either one is acceptable. It's just important to recognize it can be written either way. And so those would be our final answers. Either one of those forms is correct. Okay, number 8 would be similar. Now what we need to remember is that this fraction bar works like a grouping symbol, so it implies parentheses here. That's important because now when I multiply by I over I have to remember that I need to distribute the I on the top of the fraction. So I will get -4I plus 2I squared over 6I squared. Now, hopefully you're kind of noticing the pattern. Since I squared is -1, all multiplying by an I squared does is it just changes the sign. So we get -4I minus 2 over -6. Now, because we want all of our answers to be in standard form, that means that they need to be in the form of A plus BI. So what we need to do is to split this fraction apart with a common denominator. And we also need to put it in the order so that the i's come last. So I'm going to reorganize this to be -2 over -6 plus -4I over -6. And then I'll simplify where I can. So this becomes -1/3, +1/3 plus +2/3 I. And this would be the answer in standard form. That's important because now I can see A is equal to 1/3 and B is equal to 2/3 when we have that A plus BI form. That's always what we want. Okay? And so that is how we can rationalize the denominator when we have a single imaginary term in the denominator. Now, if the denominator has a complex number that's of the form A plus BI, so it has two terms, is that strategy of just multiplying by I over I going to work? Well, let's give it a try. If I multiply by I over I here, again, we'll have to distribute on the bottom, and I get 3I over 2I plus 3I squared. Okay, using what we know about I squareds, we get 3I over -3 plus 2I. That's rearranging for standard form. Now, here's the problem. When we split a fraction apart, we always have to keep the denominator the same. So even if I were to break this apart, my denominator would have to stay -3 plus 2I. Also, if I break it apart, I only have one term on the top, so there's nothing to break this apart. So would this still work? The answer is no. This does not work. There's no way for me to break that denominator up, and I still have an I in the denominator. What happened here, multiplying by a single I, it eliminated the imaginary term that we had. It got rid of this 3I, but it created a 2I. It made another one. So that doesn't work. What we have to do instead is a strategy that's called multiplying by the conjugate, okay? So with complex numbers, the conjugate or the complex conjugate of a plus bi is called a minus bi. So notice the a and the b are not changing. They stay exactly the same. The only thing that's changing in between is a plus and a minus. So one has a plus, one has a minus. What's the result when we multiply conjugates times each other using the distributive property? Well, let's see what we get. If I multiply using the distributive property, or FOIL if you like, we're going to do a times a. That's going to give us a squared. And then a times negative bi is going to be negative a times b times I. If we put them in alphabetical order, that's helpful. Then I can multiply positive bi times positive a, so that's positive. Again, in alphabetical order, that's going to be a times b times I. And then a positive times a negative makes a negative. B times b is b squared, and I times I is I squared. Okay, what do we know happens next? We know that negative abi and positive abi, those are going to make 0. So those are going to cancel out. I also know that this I squared is a negative, so that's going to make this a plus. Okay, so what is this left with? A squared plus b squared. That's what we get every single time when we multiply complex conjugates. I don't have any i's left, and it's just the coefficients a and b, sum of them squared. That's what we get. Notice we got rid of all the i's when we did that. And so that's the strategy that we're going to use when we have two terms in the denominator. And again, we always want to write our answers in standard form. So while we work on this, let's remind ourselves when we multiply by the conjugate, a plus bi times a minus bi is always going to equal a squared plus b squared. This would be a great thing to put on a flashcard. I would put this on one side and this on the other side, and you can quiz yourself on that. Okay? So all the conjugate does is change the middle sign. So on number 9, we have 6 over 1 minus 4i. So the conjugate of 1 minus 4i is going to be 1 plus 4i. Notice the 1 and the 4 don't change. It's just the sign in the middle. Okay? Now, when we have this complex number, 1 minus 4i and 1 plus 4i, the values of a and b are 1 and 4. That's it. That's all we care about. The I, we don't worry about. We just want the values of a and b. Because when we multiply, we're going to distribute the 6 on the top. So we get 6 plus 24i over on the bottom, it's going to be a squared plus b squared. So this is going to be 1 squared plus 4 squared. Again, no i's, just the a's and the b's. And so we get 6 plus 24i, those are not like terms, so we can't combine them, over 1 plus 16, which is 17. And now, just like we did on the previous one, we need to break it apart. So I have 6 over 17 plus 24 over 17i. That's going to be our final answer in standard form. So let's look at number 10. 3 plus I. Decide to yourself really quickly. That's our denominator. So what would the conjugate be? The conjugate of 3 plus I is going to be 3 minus I. Now, notice how the first thing I did was to add in all those extra parentheses. You don't want to forget to do that because they definitely matter. All right? Now, on the top, we're going to have to do a lot of distributing here. Okay? We're going to have to FOIL that out. But on the bottom, we're going to get a squared plus b squared. See what you can make of that. Pause your video really quickly, and I'll come back in 2 minutes with the rest of the, or 2 seconds with the rest of the work here. All right, here's what you get. When we distribute out on the top, you should get 4 terms. Remember that the minus 2i squared becomes a plus 2. And then when we combine our like terms, on the numerator, we should get 23 minus I. Then we have to break it apart to write it in standard form, which is 23 over 10 minus 1 over 10i. And that is how we divide complex numbers.